I'm not sure if you like extreme sports, but I love doing extreme math questions. So today we are going to solve an extreme quintic equation, and that's the one that we talked about the last time. X to the fifth power minus 5x plus 3 is equal to 0. And of course, the best bet for us is try to factor it, right? And okay, here we have 3 and this is 1. So 3 divided by 1 is 3. So we shall try to see if there are any easy factoring. But if you plug in plus or minus 3 and also plus or minus 1 into all the x's, none of them works. So that means we don't have easy factoring. But it's okay, don't give up. Because when we have x to the fifth power, let's try to break it to a quadratic times a cubic. And here we go. And because this is x to the fifth power, so we can say, let's say the first term is x squared, and then the next two terms we don't know. And we have to come with a general form, right? So let's just put on plus ax and then plus b. And this is similar to when we are doing partial fractions decomposition. Because later on, we just have to find out the unknown a, b, c, d, and e. Yeah. But anyway, that's the quadratic. And now let's put down the cubic, which is x to the third power. You see, this times that will give x to the fifth power. So that's good. But the rest right here, we don't know. So let's put on plus the next letter, which is c, x squared, and then the next letter, d, and then x, and then lastly plus e. And let's not put down the equal to 0 because what we have to do next is we are going to multiply this out and equate coefficients. So let's see how it goes. So this times this is x to the fifth power, and then just continue plus cx to the fourth power plus dx to the third power plus ex squared. Good, and then continue. Take ax times all that, and of course we'll line up, so we get a, and that's positive, just keep in mind, ax to the fourth power, and then plus this and that, which is ac, x to the third power, and then a dx squared, and then aex. Okay, and then one more. Take the b, multiply everything, so we get plus bx to the third power plus bcx squared plus bdx, and then plus be. So what we have to do next is that you see that the x to the fifth power match with that already. And on the blue part here, we see that when we combine this and that, we will have the coefficients for the x to the fourth power being c plus a. But if you look at the original expression here, there was no x to the fourth power term. So that means c plus a has to be equal to 0. So we have our first condition. Let's just write that down here. All right. And similarly, all this right here, okay, that's the coefficient of x to the third power, but there's no x to the third power. So that means we better have d plus ac plus b being equal to 0. And then likewise, this altogether, we have e plus ad plus bc equal to 0. And then this and that should be equal to -5. All right, so just keep that in mind because these are the coefficients of x. So we must have ae plus bd, and that's equal to -5. And lastly, of course, we have the be. That should be equal to the constant term right here, which is equal to 3. So we must have be is equal to 3. All right, so we must find a, b, c, d, e. Satisfying all these 5 conditions. And you might be thinking, wow, does that mean that we can just solve any quintic equation in this manner? No. Because this right here might not be easily achievable. It's most likely not easily achievable. But this is like the brute force way to factor the quintic equation like this. And the truth is, if a stranger on the street just hands you a random quintic equation, please don't even try to solve it this way because you don't even know if this is going to work or not. But this is the one that created it works. So let's just continue. Okay, let's do the easy one first. We have the c plus a is equal to 0. You know what? This means c is equal to -a. So we're making progress. Okay, what else do we know though? Let's do the easy one first, which is, okay, b times e is equal to 3. And of course, when we're trying to factor, ideally a, b, c, d, and e should be integers. So hopefully that's the case. So for b times e is equal to 3, we have some choices. Maybe we have 1 times 3 is equal to 3, or maybe 3 times 1 is equal to 3, or negative 1 times negative 3, or negative 3 times negative 1, right? So that's why I didn't put down any of those numbers earlier, because in fact, we will just have to really deal with them like that. And the best bet is, again, let's just guess, because what else, right? And yeah, guess and hope for the best. So for the first guess, let's just guess b is equal to positive 1 and then e is equal to positive 3. That's pretty natural, I would say. And we just have to plug in this, and also this condition into the other equations to see if we can come up with a and d, or maybe c, and see how it goes. So here we go. Let me just plug in this right here, and then this right, there's no e here, but okay, here we have d, and then plus a times c, but you know what, c is equal to negative a, so let's just multiply this and that together, so we get plus negative a squared, so I'm just going to write it as minus a squared, and then b is equal to 1, but let's put it to the other side, so this right here should be equal to negative 1, and then let's continue. Put 3 into e, and let's put that to the other side, so that should give us negative 3, and then a, don't know, d, don't know, so we have ad, and then b is 1, c is negative a, so this right here will give us minus a. But here's a small problem with this. We see that we don't know a, d, and here's the a. Yes, we have two equations with two unknowns, but the thing is that it's not so nice to solve this. You will have to kind of factor out the a, and then it's not so clean, I will say. So let me try to use this equation instead and see how that goes. So it's that said, a is a, e is 3, so the first part will get 3a, so I'm just going to put it down here. We have 3a, and then b is 1, and then we have the d, so we have d, and then that was a plus, so all that is equal to negative 5. So now let's look at this system of equations, and yeah, it's much better, right? Because now we can just go ahead and subtract the first one and the second one like this. So they will cancel, and then we have negative a squared, and then minus 3a, and then negative 1 plus 5, which is 4. Yeah, and then put this to the other side, and let's write them down as a squared minus, sorry, plus 3a, it's plus 4, it's equal to 0. Uh-oh, here's a problem with this. Can we factor this? No. We can solve it, but you know, a is not going to be a nice number. So, yeah. Try not to use the quadratic formula, because most likely we will regret. And yeah, so I'm not going to continue from here, because this, unfortunately, yeah, it's not going to give us integer a. Yeah. So what does that mean though? Well, earlier here we have the plus 4. If this is a minus 4, it will be doable. So let's change it. Because remember, we have other combinations, right? Because we can also say b is equal to negative 1 and e is equal to negative 3. So that will still work, or maybe the other way around. But that's still keep this as how they are, but we are going to use negatives. So the next case that we have is b being equal to negative 1 and e being equal to negative 3. And then let's put them into this equation. So firstly, we have the d, and then a times c, which is negative a here. So altogether, we have minus a squared, and b is negative 1. Put it to the other side, we get positive 1. And then let's plug in the rest into this equation. A is a, and then e is negative 3, so we will have negative 3a, and then b is negative 1 times d, so here we have negative d, and then that's equal to negative 5. Cool. And for this system equation, we can just add them up. So we see they cancel, and this and that together is negative a squared minus 3a. Similar, huh? It's actually the same. But here, 1 plus negative 5. Okay. Now we can move this to the other side. So we get a squared minus 3a plus 3a. I made this, but yeah, is equal to 0. And of course, we can factor this. We get a plus 4 and then a minus 1. Yeah, and that's equal to 0. So that means a is equal to 4. Sorry, a is equal to negative 4. Or a is equal to 1. Wow. Of course, you know it. There's only one correct answer for this factoring. So let's just go ahead and check. What if a is equal to negative 4? If so, then C will be positive 4. So that's C. Now we have this, and that. We will have to plug into the other equations and try to solve for D and see if the answers are consistent. If not, then that means a is equal to negative 4. It's not the answer. So we will just have to choose the other one. But hopefully we'll see. So now let's just plug into the first equation, this equation right here. So D we don't know. And then A is negative 4. And then C is 4. So together we get minus 16 from here. And then B is negative 1. And all in all, that should be equal to 0. So that's minus 17. Put it to the other side. This means D is equal to 17. Wow, D is pretty big. So I don't know. We'll see. Okay, next we will check this equation. So E is negative 3. So just plug in. And then A we know is equal to negative 4. So we have negative 4. D we don't know. And then B is negative 1 times C, which is 4. So this right here will be negative 4, and that's equal to 0. This and that is negative 7. Put it to the other side and divide it by negative 4. So we will get 7 over negative 4. What does this mean? You see, here we have 17 for D, and for this right here we have 7 over negative 4. This means negative 4 cannot be 4a because otherwise the D value is not consistent. So this right here is a no-go. But don't give up. We have another choice right here, right? Hopefully it works. Hopefully it works. And again, we just have to get an eraser to erase this and see how that goes. Alright, so when A is equal to 1, that means C will be equal to negative 1. Okay, smaller number, much better. And let's do the same thing, plug into this equation. So D we don't know. And then A times C, this times that, is just going to be negative 1. And then B is negative 1, and that should be equal to 0. So this means D is equal to 2. Good. Now, plug into this equation. E is negative 3, and then A times D, A is 1. So right here will just give us D, so plus D. And then B is negative 1 times C is negative 1. So together we will have to add 1. And that's equal to 0. But guess what? This and that is negative 2. Put it to the other side. Haha. D is also 2. So far so good. But you know what? We will still have to check this. Yeah, be sure we have to satisfy all the conditions. So no guarantee yet. Let's see. A is 1. And E is negative 3, so this times that we get negative 3. And then B we know is negative 1, so we have negative, and then D we don't know. And then that's equal to negative 5. Check this out. Put that to the other side, we get negative 2. But divided by negative on both sides, D is indeed equal to 2. Yes, we got it. We got them all. Okay, so let's see. Even though I did this a few times already, but every single time I finish this, it's very satisfying. Now let's just go ahead and put down the A, B, C, D values. So A is equal to 1, and then B is equal to negative 1, and then C is equal to negative 1, and then D is equal to 2, and then E is equal to negative 3. Alright, this is great. because now we will just get quadratic and then times a cubic. As long as quadratic we can solve. As long as we can solve the cubic, we're done. So let's see how we can continue from here. So let me just erase the board and let me know how you guys are doing. Doing good? Semester is almost done? Or you guys just watch math videos for fun? Or I don't know, let me know. And let's see. And again, just as a reminder, if a stranger gives you a quintic equation, don't bother with this. Most likely it's not going to be factorable. So yeah, do not take random people's random quintic equation. It's not safe. Okay, so A is 1, B is -1, so we put it here. So ladies and gentlemen, we will get x squared, and then we have to plus x, and then -1. So that's the first equation. Pretty good actually. You will see. And then we will have x to the third power. C is -1, so we have a minus x squared. And then D is 2, so we add the 2x. And then lastly, E is -3, so we have the -3. Alright, now we can put this to be 0. Of course, we have to make the first factor equal to 0, but that's just quadratic. And let's use the quadratic formula to solve. And you know, yeah, we'll actually end up with a number that looks similar to this. In fact, this is very similar to the back. Almost the golden quadratic equation. But not really. Yeah, but anyway. So, solve this. Let's use the quadratic formula. X is equal to -b, which is 1, and then plus or minus square root of this square, which is just 1, minus 4 times this and that becomes plus 4. So altogether, it's just going to be 5 inside, and all divided by 2 times 1, which is just 2. Congratulations! Here we have our first two solutions. So in fact, if we have the plus, we will get 0.618. So it's 1 less than the golden ratio. If we have the negative, that's the negative golden ratio, namely negative 1.618-ish. So that's the question I asked you guys to do in my Newton's method video. So that's how we get that. Okay. Now, let's see how we can solve the cubic, because remember, for the Newton's method video, I actually got the answer is about 1.27, right? It's actually the real solution from here, and then we actually have two complex solutions. So this is a cubic equation. We can of course use the Cardano cubic formula, technically the Tartaglia's cubic formula, right? A lot of you will say that, and yeah, but let me use Lagrange's way to solve a cubic formula because it's not that well known, I think. So let's go ahead and do that. So anyway, this is called the Lagrange, not multiplier. We are not doing calculus 3. Lagrange Resolvent. So what it says is the following. First off, if we have a cubic equation in the form of x to the third power plus ax squared plus bx plus c is equal to 0. In fact, this is always achievable. If sometimes we have a coefficient here, just divide everybody by that, then we can put it into this form. So that's good. So if we have this, do you know what? This right here is going to be the following. X is going to be, ready? The formula is -a, okay? And of course, we have cubic. So of course, you are expecting some cube roots. Here is the cube root. We are going to add cube root of z1. And then plus cube root of z2 all over. Not 2. That's for quadratic formula, huh? Yes, 3. So like this. Wow, this formula is so simple. No. Not done yet. What are C1 and C2? So I will just have to tell you where C1 and C2 are the solution to the following quadratic equation. We will have a z squared, ready, plus we are going to get 2a to the third power and then minus 9ab and we will have plus 27c, and then times z. And then plus parentheses a square, and we will have minus 3b, and then the third power like this. And all in all, that is equal to 0. Yeah. So Z1 and Z2 satisfy this quadratic equation. So now, it's actually not so bad, because let's mix and match. Wow, what do we need? Well, the little a is going to be -1, so let's just go ahead and put that down. And then b is going to be 2, and then c is equal to -3. And we just have to plug in and see how the quadratic equation looks like, and then just solve it. And the idea of using the resolvent is this. When you have a cubic equation, in fact, you will get a resolvent equation, which is actually 1 degree less in this situation. So we get a quadratic. And then once you solve this quadratic, which is very doable, then you just put into here. Yeah. And I actually do not know how to come with this. So if one day I know, I will try to make a video. I don't know how ugly the computation will be, but like, yeah. So anyway, now let's just go ahead and plug in numbers. So we are going to look at the quadratic equation, z squared plus, okay, let's work this out. So put -1 here, so that's -1 times 2, we get -2. And then we put -1 here, that will be, okay, AB, so that's -2 times that is plus 18. And then put -3 here, -3 times that is -81. So that's 16 minus 81. That will be minus 65. So this right here should be a minus 65. Z. Oh, much better. Now we don't have all that. All right, cool. And now that's plugging -1 in here, so we get +1, and then -3 times b. Okay, so -3 times b is -6. So we get -5 inside and third power. So in all we get -125, and everybody will be equal to 0. So that is what we have. Now let's go ahead and solve this. Again, use the quadratic equation, use the quadratic formula. So in this case, z is going to be negative this, which is going to be just 65, and then we have to do plus or minus square root of, okay, this square. So we just have to do 65 squared. What does this mean? This means, of course, 65 times 65, right? But you know how we can do it the fast way? 5 times 5 is 25. 6 times 7 is 42. And there you have it, 4225. All right, so that's this. And then, of course, we have to do the -4 times this and that. So that's just 1, so that's good. And then times that, which is -125. So 4 times this is 500, and that will be positive, so we just have to add 500. So all in all, the inside will be 4725. All right, and then everybody divided by 2 times 1, which is just a 2. Okay, that's what we have. So far so good, right? Now, ladies and gentlemen, z is equal to this. And of course, from here, we have 2 solutions. So what I mean is that, of course, we can take the first one as z1, and then the -1 as the z2. Like the order doesn't matter. So with all this, in fact, we can write down the real solution for this right here. So let's see how we are going to do it. So all that, ladies and gentlemen, x will be -a, which is -1. So that will give us +1. All right, that will just give us +1. Okay, and then plus, and let's do 1 divided by 3, right? So it's 1 divided by 3. So let's put on 1/3 here. All right, and then I'm going to do this over that, but let's put down the 1/3 in the front. So plus 1/3 times the cube root of, all right, z1 is all that, so I'm just going to write it down. We have the 65 plus, okay, can we simplify the square root of 4725? Let's just go ahead and factor it real quick. So this is 4725. We can break it down with 5. So that will give us 945. Yes, and then let's do 5 again. That will give us 189. Yes, and let's do 3. Let's do 9. Yeah, 9, and that will give us 21. So in fact, 9 is 3 times 3. So we can take out 15. So I can put down 15 here, and then the 21 will be inside of the square root. So it will be like this, and then all divided by 2. All right, and then the next one is just going to be plus, again, 1/3. Okay, and then we have the cube root of, okay, everybody, 65, but minus this time, and then 15, square root of 21, and divided by -2. And ladies and gentlemen, let me present you guys that this is the answer that we saw last time when we were doing the Newton's method. Okay, whew. Very, very nice. Alright, so of course you can just simplify that on your own, and perhaps I'll just write it down real quick. Z is equal to 65 plus or minus 15 square root of 21 over 2. Alright, so now we have 3 real solutions. Of course, I know some of you guys are going to ask me, how do we find the complex solutions? You know what, sometimes you might just have to chill a little bit. But I will give you the general strategy if you really want to see how the complex solutions look like. This right here, it's the real solution. So what that means is that we can be sure to factor this. And I'm just going to put it down right here. I am first going to call this number R, all right? So what's going to happen is that we can factor it in the sense of getting x minus r for the first factor, and then we just have to multiply by a quadratic. And of course, once we have the quadratic, we can continue to solve this with the quadratic formula. And how do we end up with that? Well, I will show you real quick. Here's the deal. I'm just going to do synthetic division for this part and then divide it by x minus r. So it will look like this. So I will draw the half box like so, and I'm going to put on the coefficients. And if you want to use the long division for polynomial, that's fine too. But anyway, we have 1, -1, 2, and -3. And then I'm just going to put on r right here. And then this is how it goes. First, you write this down, which is 1, and then you do this times that, which is r, and you put it here. And then you are going to add them up. So this plus that, let's put on r first. So we will have r minus 1. This times this, we get r squared minus r. And then add them up, we get r squared minus r plus 2. Lastly, this times that, we get r to the third power minus r squared plus 2r. And of course, you add this right here, which altogether r to the third power minus r squared plus 2r, and then minus 3. And you might be wondering, like, why do we have this? But guess what? This part is actually very nice, because what's r? R is the solution to this cubic equation. And you see, we have r to the third power minus r squared plus 2r minus 3. So that means this right here must be equal to 0. Now we can just write down the quadratic expression right here. This is going to be 1 degree less, which is going to be x squared, technically 1x squared. And then next we will have r minus 1. That's the coefficient of x. And then I'm just going to erase this. And then I'm just to put on that for the constant term, which is plus r squared minus r plus 2. Yeah, so this right here will be the factoring for that. And of course, if you are serious, you can put this right here, maybe copy and paste, into this r, and this r. And then use the quadratic formula. Negative b plus or minus square root of blah blah blah. And then you put this for b, this for c, and then you have that. I have no idea how the answer would look like. I don't know how big is it. I'm not even going to try. I thought about it. I thought I was going to try it, but no, I'm not going to do it. I am not going to do it. But this is very satisfying though. Yeah, whenever you can solve a very nice quintic equation, in this case, it's pretty extreme. It's an extreme quintic equation. It's extremely satisfying. Please let me know what you guys think. And I will be emotional if somebody really do what I said earlier and then find out the complex solutions. Yeah, if anybody does that, it will be pretty cool, but don't do it, seriously. Anyway, hopefully you guys all like this. Check out my next video right here, and I'll see you guys there. That's it.